Hello, Alexander. My physics students, hope all is well with you. I want to just stress before I move on to the problem that we're all in this together, and to post under the message board, and definitely email me if you're having issues, whatever issues. Please go ahead and email me. Hey, I want problem 15 done. Can you go ahead and do it? It could be that simple. I just did some more discussion posts. Can you update my grade? Or I just watched the PhET simulations. Can you put that score in? Or just a general question like, why did this problem do this? Or why did that problem do that? And I will definitely address every question that comes in, and we will get through this together and learn. And if you have questions on anything, please email me, communicate with me. That is one of the most important things you can do right now. So we're just trying to work through this together and figure these things out. So this is my first video on circular motion. It is a good unit, and it uses a lot of the equations you know and love. So I think it's a good unit for us right now. So without further ado, let's go to problem 1, the wheel. Okay. Now, in problem 1, we're going to do part 1 first. Okay. We have a wheel, and it has a radius. Okay, we'll call it R because I'm out of room there, and the radius is 4.57 meters. So if you think about this wheel rotating, okay, one trip around, what's one trip around for each of these? In terms of the angle, one trip around, in terms of this interior angle, is called one revolution. It's also called 360 degrees, and it's also called 2 pi radians. Okay, everyone's favorite unit. Now, the linear distance, if you were traveling on a bike or in a car or whatever, one trip around would mean a different linear distance based on the size of this wheel. If it's a gigantic wheel, one trip around is a large distance you traveled. If it's a small wheel, one trip around is a small distance. It matters on the size of the wheel. And more specifically, one trip around is one circumference. One trip is one circumference. Okay, okay, you know how to spell it. There you go, circumference. All right, and so one circumference, what is the formula for circumference? 2 pi times the radius, right? 2 pi radius. That's a circumference. That's one trip around, one revolution, 360 degrees, 2 pi radians. Okay, so we go 21.2 degrees. Well, that's not a full trip around, right? What fraction of the entire wheel did we go around? 21.2 over 360. That is the percentage of the entire radius, of the entire revolution that we went. And all we have to then do is multiply by 2 pi times our radius, which is 4.57. And that equals for us, where is it? Apologize, slow on this. Looks like 28.7 meters. Oh no, sorry. That was the circumference. My circumference is 28.7 meters. My distance after I multiplied by the fraction was 1.691 meters. And that's my answer to the first one. Okay, so let's go to the next one. So how far did we travel if we went through this many radians? Well, how many revolutions? Let's turn it to revolutions. That's the easiest thing to do. 21.2 radians. And how many revolutions is that? Okay. Well, 2 pi radians equals 1 revolution. And so when we do this, 21.2, sorry, 21.2 times divided by parentheses 2 pi. Please put your 2 pi in parentheses when you divide it. Okay? And we get 3.37 revolutions, or trips around. Please put this in parentheses. Okay, that many revolutions, 3.37 revolutions. Well, what's one revolution? Well, one circumference. Well, what's my circumference? It's 28.7. So all I have to do is multiply by 28.7 my circumference, and that will get us our total linear distance that we traveled. And in my case, it is 96.9 meters. That's it. Okay, now 21.2 revolutions. It's already in revolutions for us. And how far is one revolution, one trip around? How far is it? Well, it's one circumference. So all we have to do is multiply by the circumference, which for me is 28.7 meters, and we get 608.7 meters. There we go. Try this problem out. Let me know how it goes. And if you're still struggling, or even if you get the problem right and would like a better explanation, I would be more than happy to do that. So please email me and let me know. Thanks.